To understand what is weight, I'll show you two films and then I'll ask you a question. Let us see first film. Here is a man who is coming down the stairs and he will fall down. Let's see how it happens. So you saw how men fell down. But let's now go to spacecraft which is moving around Earth and see what happens to man there. You see the man in the spacecraft.
Now into the service module. The very aft end of the Russian segment. Next stop will be the first
He's
juncture
actually floating.
in the Russian segment, where we'll look down first. Bobby and Mike begin doing some EMU treatment.
So what actually you see here is the astronaut floating in the spacecraft. He's not falling down like the previous case that we have seen. Question is, why is this difference? Why does a man fall here? However, in the spacecraft he floats. So if you try to answer this why, you will understand the concept of weight. The reason is that any two objects with mass, they pull each other. For example, the two apples here will pull each other, but for such small masses, the pulling force between two apples is so small that we never notice it. But when one mass is very large, like for example we have our Mother Earth, such large masses on any body apply a force which we can notice very easily. Because of this, things start falling. That's how Newton discovered law of gravity when an apple fell down on his head while he was sitting under apple tree. So Earth, because of its large mass, very large mass, creates a pull on every object, which is what we call weight. And it is because of this pull of Earth that this man fell down. Whereas in deep space, this man experiences zero effective pull, and therefore there is no pull and he doesn't fall. This pull of Earth is not constant everywhere on the surface of Earth, and it changes, and it depends on where you are, whether you are on the North Pole or on the South Pole or which part, or whether equatorial or wherever. So it actually changes depending on where you are. Pull changes, therefore weight will change depending on where you are. But in general we can say a 1 kg mass, if you leave it, then it starts moving towards Earth with a rate of 9.8 meters per second, which is the acceleration, and this is then called 1 Newton or 1 kilogram force. That is the force acting on 1 kg block is the pull of the Earth, and therefore we will say that this is the weight. However, if you replace this 1 kg with 1 gram, then the force acting or the weight of this will be called 1 gram force. You can measure weight by spring balance. Weight is attached to this end, then Earth actually pulls this down, which is stopped by the spring balance. If spring balance was not there, this would have fallen to Earth. They stopped by the force which is equal to the weight, and the reading here is actually what gives you the value of this weight.